The method solving for x directly is used when we have a quadratic equation and we only see x once in the equation. Example number 1. We have a quadratic because the highest power of x is squared, which tells us that we'll get 2 answers. And we only see x once in this equation. To solve for x directly, undo the order of operations. I need to undo what's happening to x in this problem. So to get rid of this plus 3, I'm going to subtract 3 from both sides of the equal sign. Now I'm left with x squared. To get rid of squaring something, the inverse of squaring something is the square root. And if I square root the left side, I need to square root the right side. So I'm left with x equals 4. So where does the second answer come from? Well, it comes from this step right here. Whenever I'm solving a quadratic equation and I add in the square root, I have to add in a plus or a minus in front of that square root. So I will have a plus or a minus right here, which means I have 2 choices for x. X can be positive 4 or x can be negative 4. Which makes sense because if I look at this step right here, 4 squared is 16. And negative 4 squared, negative 4 times negative 4, is also positive 16. So I do get 2 answers, positive 4 and negative 4. In example number 2, we have a quadratic and we only see x once. So I'm going to subtract 1 from both sides and then take the square root of both sides. Now, unlike problem number 1, 16 is a perfect square, which simplified down to 4. 40 is not a perfect square. So I need to simplify this square root of 40. To simplify the square root of 40, I'm going to break it apart into a factor of a perfect square times another number. So 40 is 4 times 10. I picked 4 because 4 is the biggest perfect square that divides 40. Now I can distribute that square root to the 4 and to the 10. So I'm left with 2 square roots of 10. And I should get 2 answers, so I need to go back and put in this plus or minus in front of the square root. So x equals 2 square roots of 10, or x equals negative 2 square roots of 10. In problem number 3, again a quadratic where we only see x once. Subtract 4 from both sides. Divide by 13. And then take the square root. I'm going to add in the plus or the minus. So x equals plus or minus the square root of 18/13. Now I need to simplify the square root of 18/13. I can distribute the square root to the numerator and to the denominator. So I have the square root of 18 divided by the square root of 13. Now I can treat the numerator and the denominator as separate problems. The square root of 18 can be simplified down to the square root of 9 times the square root of 2. Which simplifies down to 3 square roots of 2 over the square root of 13. At this point, I need to rationalize my denominator. I can't have a square root in the denominator, So I'm going to multiply by 1. But not just any 1, 1 over 1. But I'm going to turn that 1 over 1 into the square root of 13 over the square root of 13. And the square root of 13 over the square root of 13 is 1, so I'm really just keeping this number the same, but changing its form. To multiply fractions, I multiply straight across. 3 times the square root of 2 times the square root of 13. To multiply square roots, I can rewrite them underneath one square root symbol. 2 times 13 is 26. And the square root of 13 times the square root of 13 is going to be the square root of 13 times 13, which is a perfect square. The square root of 169 is 13. So my final answer is positive 3 square roots of 26 over 13, or x equals negative 3 square roots of 26 over 13. Let's look at example number 4. Again, we have a quadratic because x is being squared, but we only see x once in this problem. Even though it's inside of a binomial that's being squared, it's only written one time. So we need to undo the order of operations. To undo the order of operations, I want to get rid of this 2 first. To get rid of this 2, I don't want to distribute. I want to divide by 2. Now at this point, the entire left side of my equation is being squared. When the entire left side is being squared, to undo that, I'm going to square root. And since I added in the square root, I need to put the plus or minus. Now these two operations are inverses. I'm left with just x minus 3 equals plus or minus 2. Now to solve for x, I need to add 3 to both sides. I have 2 plus 3, or negative 2 plus 3. So x equals 5, or x equals 1. I still get 2 answers, but in this case, I can simplify because these are both integers. Number 1 and number 4 are slightly different problems. I could just subtract 3 from both sides right away in problem number 1, but I had to wait to get rid of this minus 3 until after I got rid of the things around the parentheses. Last example, example number 5. I have a quadratic, but this time I see x twice. So if I try to solve for x directly, I end up with this. And if I look, there's a monomial I can factor out here. But at this point, I'm stuck. 2 things multiplying together to give me 10, I can't guarantee what either one of these is. So for this problem, there has to be a different method to solve. So to solve this problem, I want to solve by factoring. The clue that tells me solve by factoring is I have a quadratic, an x squared, but I see x written twice in this equation. So I have x squared plus 3x minus 2 equals 8. So in order to solve by factoring, I need to set the equation equal to 0. And then factor the left side. I I need a positive 3, so I want the 5 to be positive and the 2 to be negative. And now this problem is different than right here. Here I can use the zero product property. Two things multiplying together to give me 0. One of those two things has to be 0. I can't do that here. I can't guarantee that either x is 10 or x plus 3 is 10. I can when I have it equal to 0. Solve for x. Solve for x. I still get two answers. So when solving for x directly, I have to have a quadratic equation where I only see x once. Even a problem like number 4, I have to undo the order of operations, always simplifying my answers down to fractions where my radicals have been simplified down. A problem like number 5, I can't solve for x directly because I see x twice. That means I have to solve by another method, and I can solve this one by factoring.